Hey guys, this is Mr. Sal. We got a quick lesson here on the Pythagorean Theorem. So the Pythagorean Theorem is a conditional statement. If you have a right triangle, then c squared equals a squared plus b squared, and c equals the square root of a squared plus b squared. Now we use this formula specifically to solve for c, but what are a, b, and c? To figure this out, we'll have to start with the right triangle, like it says to, if you have a right triangle. And we have that right angle right there, which is squared in kind of like this here, right? Well, that angle is made up by this side length and also this side length. Those two lengths, or sides of the triangle, are called legs. So when we talk about parts of a right triangle specifically, when we say a leg makes up that right angle, and it takes two sides to make up an angle, so we need two legs. Finally, we have this third side. That is the longest side always of a triangle, and that is called the hypotenuse. Well, as it turns out, in ancient times, dating all the way back at least to ancient Egypt, they found that if you took the two legs, squared them, and added them, so the sum of the squares of the two legs, you would get the length of the hypotenuse as a square as well. So looking at these three parts of the right triangle, what I'm saying right here is if I took the squares of the two legs and took their sum, then it would be the same thing as taking the hypotenuse squared. Now let's think of this even in a different way. What this is actually telling us is if I took each of those side lengths and made a square out of them, hopefully if you're taking notes on this, your squares look a little bit better than mine. Well, we're saying that the green square is not only bigger than the red and the purple ones, but it's also saying that if I took the area of the purple and the red squares, that it would equal the area of the green square. So the area of the two squares added up give us the hypotenuse as a square, and when I have the area of a square, all I need to do to find the side length is to square root that, and that is what is shown up here in this part of the formula. So we have to keep this in mind as we look to solve these problems, whether we're solving for a leg or a hypotenuse. We need to know that so we know where the unknown goes. Then we'll just kind of use our principles of equality to solve for whichever value we're trying to find. So let's go back to that formula there at the top. What we're saying is that the hypotenuse, because we didn't want to write this out all the time, right? The hypotenuse is a c value. One of the legs is going to be an a value, and the other leg will be an b value. And it doesn't matter which is which, but again, when I take those two legs squared and their sum, it will equal the hypotenuse squared. So it doesn't matter which way we look at it. It means the same thing. It's just not writing it out with the same words, I guess. But c is the hypotenuse, and then a and b are legs. Now, just real quick, why do they call it the Pythagorean Theorem? That is because back in ancient Greece, there was a dude named Pythagoras, and he had a huge following, and they made this famous. Like I said, there were older civilizations that had this same formula to solve for missing sides of right triangles. Now, again, that's not a lot of history, but you could Google Pythagoras and kind of check him out that way too. Alright, so what about this problem? Find the missing length of the triangle, and they probably should have said it was a right triangle. Now, to do this, of course, with the knowledge that we have at this point, we need to assume that that is a right triangle, which is fine. And to solve this right triangle, we'll need the Pythagorean theorem. So I'm going to write it out like this. Of course, if you needed to, you could write the a squared plus b squared equals c squared. Now, again, we need to notice where that right angle is. And it's created by this side length of 6, so I'm going to replace this leg with 6. And then we've got another side length that makes up that right angle. That's 8, so I'm replacing that leg with 8. And I know when I square these two together and then add those two squares, I get the hypotenuse, which we don't know right now, so I'm going to say it's x. You know, actually, just to keep it kind of consistent, we'll say it's a c value. So that would be the hypotenuse as a square as well. So let's evaluate these squares. So 6 to the power of 2 is 36, and 8 to the power of 2 is 64. And we'll just fill in the rest of this. So c squared is 36 plus 64, which when I combine those two, I would have an area of some square with the side length of c, that is 100. And then how do I solve this? So what do we do in this situation? As it turns out, it's just the same thing we would do to find the side length of a square. And that would be to square root both sides of this equation, on both sides of the equal sign, I should say. So I'm going to square root that c squared, and also the 100, which I can punch into the calculator. Now the square root of something squared is a perfect square, so that's just going to be a c value. And the square root of 100, it's also a perfect square, that's 10. And that would be our answer for this problem. So that's how we use the Pythagorean theorem to solve for a missing hypotenuse. So in this problem, it's going to be just a little bit different because we're not solving for a hypotenuse. As we can see, the right angle would be right here, and then the x value is a leg, and this 3 value is a leg. So 5 is the hypotenuse in this case. So when I go to the Pythagorean theorem in this case, the hypotenuse now is that 5 length. The red leg that I have is the x value, and then the purple leg would be the 3 value. Now it doesn't matter which of those values you say is which leg, so I could have put the 3 in as the red leg and the x as the purple leg. It doesn't matter which of those two we replace because they're both still legs. Now this is the squares of both and the sum. It needs to equal the hypotenuse as a square. So let's go ahead and square those values, 5 squared and 3 squared, and that would give us 25 and 9. Of course, we still got that x squared there. So right now I've got 25 equals x squared plus 9. And we have an equation at this point which we need to solve. And using the principle of equality, the subtraction principle of equality, I want to isolate that x squared. So I'm going to subtract 9 from both sides of the equal sign, and that zeroes that out. And then I get 16 equals x squared. Now this is the same idea. It's the square of this red leg right here, which means I could take the hypotenuse as a square and subtract the purple square from that area. And so I'm just solving for the side length of a square, which means I need to square root both sides of the equal sign. So that makes that an x, and the square root of 16 is 4. And that right there would be our answer. So, given a field 205 feet by 72 feet, how far is it to walk from one corner of the field to the opposite corner, to the closest tenth of a foot? So we will be evaluating these ones. Let's go ahead and draw a picture of this to see if it helps. It doesn't have to be drawn to scale, but let's say that this is the field. Then I would have, this would be the shorter side, so that's at 72 feet. And the longer side is at 205 feet. And yes, we do get to assume that this is a rectangle. Well, how long is it from one corner to the other? So we'll just connect those two. And hopefully we see, since it is rectangular, that this is a right angle right there. So I'm really just looking at a triangle, trying to figure out the hypotenuse. So something like this right here. Well, that means we can use the Pythagorean theorem. And I've got one leg there at 72, and the other leg there at 205. And again, it doesn't matter where you put those. The hypotenuse, we'll just say some c value right there is the hypotenuse. Of course, if I square the two legs and take their sum, then I get the hypotenuse as a square also. So let's go ahead and evaluate the 72 squared and the 205 squared. So I have 5,184 and 42,205. Of course, that would be our hypotenuse squared equals that sum. So let's go ahead and add those two together then. So our hypotenuse is, as a square, is 47,209. And then finally, to solve this, we'll square root both sides so that we just get the hypotenuse. And this time we're not going to look to simplify this as an exact value because it told us to round to the nearest tenth. So I'm going to plug it into my calculator. The square root of 47,209. And my calculator gives me 217 point, and we want the tenth of a foot. So I had 27, so I'm going to round that to 3. And yes, we do need to label this because it is a word problem. So 217.3 feet would be the distance from one corner of the field to the other, to the nearest tenth of a foot. A 10-foot ladder is placed against a building. If the base of the ladder is 6 feet away from the building, how far up the building will the ladder reach? And again, we're looking to round to the nearest tenth. So here's what we got. We got some kind of house right here, or building. And then against that building, we're placing some kind of ladder here. And then the ladder is based on the ground, some distance away from the building, which it did say, I guess, right here was 6 feet away from the building. So that's 6 feet from the base of the ladder to the base of the building. And it did tell us also that the ladder is 10 feet. So there's 10 feet right there. And this is actually a situation of the Pythagorean theorem because we get to assume that that's a right angle. So I've got my hypotenuse, which is the ladder length at 10 feet. Then I've also got the leg at 6 feet. And then the height of the building, or how far up the building the ladder will reach, if it's the base of it is 6 feet away from the base of the building, would be the height that the ladder will reach onto the building, which we don't really know there. So I'm going to use an x value on that. So if I took the squares of the two legs and added them together, I would get the hypotenuse as a squared. So let's go ahead and evaluate those, 10 squared and 6 squared. So I've got 100 equals 36 plus that x squared. And from here, we're going to solve this like an equation. So subtract 36 from both sides. Of the equal sign gives me 64. That zeroes away, and we'll drop that x squared. Now, of course, we don't want x squared. We just want x. So I am going to take the square root of both of these. And the square root of x squared is x. The square root of 64 is 8. Just don't forget as well, because 64, we didn't need to round to the nearest tenth, that it's not 8, it's 8 feet in this case. So the answer is the building. How far up the building will the ladder reach? 8 feet if we have it, the base of the ladder 6 feet away from the base of the building. A 16-inch laptop has a screen that is 8 inches tall. How wide is the screen? So let's go ahead and draw a picture again. Now I kind of assume it takes on the figure of a screen, which would be a rectangle like this. Now it says it's a 16-inch laptop. That's the diagonal length of the laptop, so that would be this length here. And it said it's 8 inches tall, so that would be 8 inches as this length right here. Of course, we can see that these two will make up a right angle because it's rectangular. And so I really just have this triangle right here, which is a right triangle. Now again, that diagonal length, it said it was 16 inches. And we need to solve for this leg length right here. So we can go back to the Pythagorean theorem, which gives us the hypotenuse squared equals the leg squared plus the other leg squared. And the hypotenuse in this case is that 16 inches. The one leg that we have is 8 inches. And we have the other leg, which we don't know yet, at x inches. So if I take the sum of the two squares of the legs, I get the hypotenuse as a square as well. Let's go ahead and evaluate these for their actual values. Of course, x squared will just be x squared. So 16 squared is 256, and 8 squared is 264. So 256 equals 64 plus that x squared. I'm just solving this like we would a regular equation at this point. Subtract 64 from both sides of the equation. So I got 192 equals that bottom length of the screen squared. And to solve that, we will square root both sides of this equation, which gives me x, the length of the screen. And there may be two ways it wanted to answer. It didn't tell us to round this, so I could say that it's 8 square root of 3. That's simplified in inches. Or I could plug this in to my calculator and figure out what the decimal value is, which appears to be 13 point to the 10th. That would be 85, so that's going to round to 9. So either 8 square root of 3 inches or 13.9 inches. Either one will work in this case because it didn't specify. But if it did say that it wanted the exact value, you'd say 8 times the square root of 3 in inches. So that does it for this lesson. Thanks for watching, you guys. I hope it was helpful for you. If it was, please like the video and subscribe to the channel. And leave a comment below.